So the topic now,
Trigonometry ratios of right triangles.
yeah, special right triangle.
Special.
Yeah, so the word special must be there. In this particular case, yesterday we were dealing, or 2 classes ago, we were dealing with right triangle. This time around, it is special right triangle. So you can call it trig ratio of special right triangle. Okay, so now what are these special right triangles? Who has a hint? Who has an idea of what you think they are?
45, 45, 90 triangles and 30, 60, 90 triangles.
Okay, somebody said 45 degree, 45 degree. I like the way you say it, 90-degree triangle. And what else did you say?
30, 60, 90.
30, 60, 90 triangle. I like that way of that's another great way of saying it. So that's the special. These are all in degrees. These are all degrees. Okay, so these are special right triangle. Very soon you will discover why they are special. And fortunately also, all other right triangles are actually derived from all other triangles are actually derived from this special triangle, one way or the other. Okay, so now how do we create 45 degree? So let's start with how we can create 45 degree and what makes it special. So the special triangle angles are 45, 30, and 60. All right, so how do we create a special angle? Okay, so now draw a unit square. Everybody draw a unit square. Unit square means that the length width is 1 unit. 1 centimeter, 1 meter, 1 foot, 1 yard, 1 kilometer, 1 mile, 1 whatever. So I'm going to sketch mine. Okay, so that's my unit right triangle. Actually, unit square. So in this unit square, we have length is 1, width is also 1. And all the angles are what? All the angles are 90 degrees. Now that we know that all the angles are 90 degrees, so there is an imaginary line that divides a quadrilateral into 2 equal parts. In this case, since this is a square, you can draw that imaginary line from one vertex to the opposite vertex. So you just draw a line and it happens to have a name. So what is that name? The name of this line I just drew. It starts with a D. Diagonal, yes, it's diagonal, okay? So this line is diagonal. Okay, now because this was a square and each of them is 90 degrees, so if we divide 90 degrees into 2 equal parts, what will one angle be? 90 divided by 2.
45, right?
Okay, 45. Thank you.
I thought it was like 3.
Okay, so yeah, 90 divided by 2 is 45. So now we have a triangle. You see, this is 45, and this is also what? 45. That's how this 45, 45, 90 come to be, and this is 90 degrees. So if you want, you can separate and remove one triangle out of it and just redraw it. Just redraw the shape. So you have 45 degree here. You have also 45 degree. You have 90, making it 180. This is still 1, and this is still 1. So now our goal right now is to determine this diagonal, the length of the diagonal. Our goal is to determine the length of the diagonal. So considering this is a right triangle, how do you think we should be able to determine the length of the diagonal? What formula can we use? What relationship can we just apply to determine the missing side of a triangle? Pythagorean theorem. Thank you. Pythagorean theorem. So you may use, you can say use with confidence. You say it with confidence. So use use Pythagorean theorem to determine the missing side. So everybody, I want you to apply Pythagorean theorem and tell me this side, the side here, the missing side. If you like, you can label it as A, B, and C. And this becomes your small c. This becomes your small a. And this becomes your small b. So you have 1 minute to get me the value without using calculator. So do not use calculator and leave your answer in square root form if you encounter a radical. You have 1 minute. What was the Pythagorean theorem again? Always write the formula. Write the formula first before you begin to do any other thing.
A squared plus B squared equals C squared.
Okay, that's correct. So that's you can also write it as C squared equal to A squared plus B squared. Or you can say A squared plus B squared equal to C squared. So go ahead and plug in the number. Let's find out the value of C. Yes, go ahead. What's the solution? Value of C. I'm listening, guys. Who has it? By the way, looking at the triangle, what's A? What is A?
1.
A is 1. So make the substitution and move on. 1 squared plus, and how about B?
1.
1. So make the substitution and move on. Keep working. And then what does it give you eventually? 1 squared is 1 times 1. What does that, what is that?
1.
Yes. So you have 1 plus 1, which is 2. So what is, this is C squared. So C squared, square root of C squared, square root of C squared equal to square root of 2. So that C is what? C is equal to what? Square root of 2. Guys, you have to be confident. You have to be confident. You have to be confident. Whether your answer is right or wrong, you have to be confident. Nobody kills you if your answer is wrong. It is part of the learning process. And the good news is that you are going to be corrected. That's the good news. Okay, so now we can look at our triangle, and now that we now know the side of the C, we can now put the square root of 2 there. We can just come back here and put square root of 2. Okay, so this is still Pythagorean theorem, which you did in 7th grade, 8th grade. Now let's now go to our trigonometry. So we are going to use trigonometric ratios, and we are trying to get the trigonometric ratio of 45 degrees. And let's see. So using trigonometric ratios, you can say using trig ratio SOHCAHTOA. You can't go wrong with SOHCAHTOA. That's fundamental. You must remember it. If you cannot remember SOHCAHTOA, there's no way you can pass trigonometry. Okay, so now we are trying to find out sine 45 degree equal to, then cos 45 degree equal to, and then tangent 45 degree equal to. So these are the first three. And then once we are done with that, we come back again and do cosec 45 degree, secant 45 degree, and cotangent 45 degree. Okay, so now get back to your triangle again. If you like, you can write it close by. You can write it, I will rather redraw it myself. I'll just redraw my triangle. I still have my 45 degree. I have my root 2. I have my 1. I have my 1. Now look at this triangle again. Which side is the hypotenuse? Which side is the hypotenuse? What's the value of the hypotenuse? Looking at this triangle. What?
Square root of 2.
Yes, that's correct. Square root of 2 is the hypotenuse. So this side is the hypotenuse. So how about the opposite?
1.
Opposite is actually 1, but don't be deceived because there are 2 1s there. The only one that is opposite is this side, this one. The other side is adjacent. Okay? So now, I mean, if this is the requested angle, so this is the opposite. If we were considering the angle here, then this would have been the opposite. Okay, so now based on your Socatua, so what would be sine 45 degree? Sarah, go. I'm going to call names randomly. Sarah, go. What is sine 45 degree? Take a look at this triangle and tell us. Sarah, it's your turn. Unmute yourself and give us a result.
Wait, let me put in the calculator.
You don't need calculator. So just use the numbers that we have here. Leave it in fraction. No need for calculator. We will come to the calculator later on, but not right now. Yeah, go.
1/1.
Okay,
Oh,
sine is what?
over square root of
Look at the Socatua again. Sine is what?
opposite over hypotenuse.
Okay, good. So now which one is the hypotenuse? Look at the triangle again.
Okay, so it's 1 over the square root of 2.
Exactly, yes. So it is 1 over square root of 2. 1 over square root of 2. Thank you. Next, I'm going to be calling names randomly. Tyler, Allen, it's your turn. What is cosine 45? Please. Tyler.
Oh, 1 over.
Always look at the definition of
1 over square root of
Socatua.
2.
Hold on. Always look at the definition of Socatua and also look at the diagram that you are trying to figure out. So now repeat your answer, please.
1 over square root of 2.
Okay, explain.
Adjacent over hypotenuse.
All right, so adjacent is 1. Thank you. That's correct. 1 over square root of 2. So sine 45 and cos 45 are exactly the same thing. Now let's go. Next, Brenda, go. What is tangent 45? Brenda Carino, go.
Tangent 45, wouldn't it be 1/1?
Yes, 1 over 1 is what?
1.
1. Thank you. All right. Next, Abu, it's your turn. What is cosec 45?
Square root of 2 over 1.
How did you get that?
Because you have to flip the formula.
Thank you.
Yes.
Thank you. Thank you. So you have to see cosec is an inverse of sine. So cosec would be just flipping it. So which is hypotenuse over opposite, and which is also the same thing as saying square root of 2 over 1. Thank you. Next, Terry Scott, what is secant 45?
Secant 45 is square root of 2 over 1.
Okay, explain, please.
Because like secant is like the opposite of cosine, so you just flip it. And then,
You just flip it as well. And then adjacent in this case is 1, and the hypotenuse in this case is 2. So if you flip it, you're getting the same result. All right, so it is also, let's write it briefly, hypotenuse over adjacent. So this is the same thing as root 2 over 1. Thank you. Next, if you're dealing with cotangent, always start with tangent. What is tangent? Opposite over adjacent. So go. What is cotangent?
1/1.
1 over 1. Thank you. So cotangent is still adjacent over opposite, and that's still 1 over 1. All right. So now that we have derived these numbers in terms of fraction, let's verify them. Let's verify them. Maybe we are wrong, or maybe the formula itself is wrong. So let's use a third party, which is a calculator. Now you can pull out your calculator. You can use a cell phone calculator, then press exactly what I'm asking you to press, because we are going to make a verification now. So I'm going to share a new screen. Okay, so I'm going to share new, and then I will pull out my calculator. Just use your calculator while I'm trying to pull out mine. So what is, press sine 45 in your calculator, and let's know the result. Just press sine 45 like you pressing the key sine and 45 and closing. Okay, give me one moment. Let me share again. Okay, somebody said sine 45 is 0. What?
70710.
Okay. Now let me write it down. Write it down so that then also press, another person press 1 divided by square root of 2. Let's see what the result is. 1 divided by square root of 2. Cynthia, go. Help us. 1 divided by square root of 2. Use your calculator. Hello? Okay, Jonathan, go. It's your turn. Use your calculator. What is 1 divided by square root of 2? Quickly.
Hold on, I'm still looking for it.
No. Use calculator. Use calculator.
It's 0.70710.
Is it the same number?
Yes.
Okay, so now everybody just get ready because I can call your name at any time. Get ready. All right, so here's what I asked to do. Sine 45, and then you hit enter, boom. It gives you the result. Then I said, okay, do this one. 1 divide by, press a division sign, second function, square root of 2. And then you move away from the square root of 2 and you hit enter. Boom, the same number. So we are correct. Now here's the good news. Now this number, the second one, this is how all these functions that are on your computer or your calculator, these are how they are derived. You see, this is how they are derived before they were coded. Before they were coded into the computer, into the microchip of the calculator, before the program can run it. It started like this. It started like the 1 divided by square root of 2. That's how it started. If you're learning computer science and stuff like you're trying to write a code using something like Java, at some point you will start writing a programming code that will solve this type of problem. And that's how they are coded, just in case you don't know. And this calculator was made in Texas. So which means people in the United States here worked on these things to code it as we're using it. So now you can use what I just did right now to verify all those other trigonometric ratios. So now we can move on. Now we have done 45. So now we are going to do a similar thing using the other set of angle, which is 30, 60, 90. Another set of special angle. So first of all, so we are trying to deal with 30 degree, 60 degree, and 90 degree triangle. Okay, so now let's start by trying to create a triangle that has this dimensions in terms of angle. So let's draw an equilateral triangle. What's the total number of angles in a triangle? I need help.
3.
Okay, that's the number. But how about the degree, in terms of degree?
Isn't it 100?
No, 180. Yes, that's 180. Now, since it is 180 degree, if you divide it into 3 equal parts, what will one angle be? 180 divided by 3?
60.
60. Okay, so what that means is if you draw every equilateral triangle has 60 degrees. All equilateral triangles is 60 degrees. Each of the angle is 60 degrees. What that then means also is if you divide one of the angles by drawing a perpendicular line or by drawing an altitude or perpendicular line to the base line. So you are going to have, when you divide 60 into 2, you are going to have 30 degrees, and then you have 90 degrees. So you have another right triangle with 60, 30, 60, 90. Okay, so now if, for example, the length of each side of this equilateral triangle is 2. If it is 2, so that means this side is 2, and that means from here to here is 2. And because we splitted it into 2 equal parts, that means one side of it is 1, the other side of it is 1. Okay, so we just created a right triangle out of equilateral triangle. So let's redraw it. We can redraw it, and we have 60 degree here, we have 30 degree here, and then we have 90 degree here. So this is 1 and 2, and then we are missing this side. So how do we determine this missing side? Again, this missing side, how do we determine it? Using Pythagorean Theorem. I want you to work on it. I give you 1 minute to do that. You can label your angles, the vertices, you can label it as A and B and C. So, which means we are looking for small b. We have small c and we have small a. So, ladies and gentlemen, let's go. What is small b? Use Pythagorean Theorem quickly.
30.
It has to be not 30 degree. It cannot be 30 because it cannot be 30.
Oh, I see. I see.
I got 2.2.
Leave your answer in radical form.
Square root of 5.
Square root of 5 then.
Okay, you said square root of 5. Who said square root of 5? You, Abu. Is that Abu, are you?
We both do.
Okay, now prove it. Prove it. Explain. I'm going to write exactly what you say. So go. Start with the formula.
A squared
Form-
plus B squared.
A squared plus B squared equal to C squared. Yeah, go ahead. Next.
1 squared plus 2 squared.
1 squared plus,
2 squared.
how is it 2 squared? Look at B. B is unknown.
Oh,
So that's 1 squared plus B squared. Okay, go ahead. C is known.
equals
It's unknown.
2 squared.
Yeah, 2 squared. Okay, go ahead. Tyler, it looks like your voice. Tyler, go. Yes. So what is 1 squared, ladies and gentlemen? 1 squared is 1 plus B squared. And what is 2 squared on the other hand? 4. Okay. So what's next step at this point? Yeah, you subtract 1 from both sides. So you have 1 minus 1 plus B squared equal to 4 minus 1. So you have B squared equal to 4 minus 1 is 3. So B will be square root of 3. Okay? So B is square root of 3. So we come back here and we can insert our square root of 3 here. And that's B. So this way now we have, let's redraw the triangle so that it becomes less messy. So we have square root of 3 here. And then here we have 60 degrees. Here we have 30 degrees. And here we have 2. So now the question becomes, which one do you want us to do first? Do you want us to do 30 degrees first or 60 degrees? Hello, guys.
60 degrees.
60 degrees. Okay. So if you want us to do 60 degrees, I suggest just cross out this 30 and pretend as if it doesn't exist so that it will not confuse you. Okay. So now identify your hypotenuse now. Identify your hypotenuse. Which side is the hypotenuse?
The 2.
Yeah, the 2 is the hypotenuse. Thank you. How about the opposite?
Square root of 3.
Yes, thank you. That's correct. And then how about the adjacent? Of course, the other side.
1.
Yeah, adjacent is 1. So now we are going to do exactly what we did previously, which was we are going to find sine 60 degree, cos 60 degree, tangent 60 degree, and of course these are all equal to, and then we repeat the process and do cosec 60 degree, secant 60 degree, and tangent. All right, now starting with Raiz, go. What is sine 60 degree?
Give me a minute.
Okay. I'll give you 30 seconds. Catherine Fuentes, are you ready? Catherine, if I call your name and I don't get a response, my assumption is that you are no longer on the screen.
I'm here.
Okay, good. So now you don't have to get it right. Just give us a response. So what is sine 60 degree? What is sine 60 degree? Sine. We're starting with sine.
I'm not sure.
Okay, now next person, Leslie, it's your turn. Leslie, go. What is sine 60 degree? Remember, everybody, you always starting with SOHCAHTOA. You are always starting with SOHCAHTOA. How many times will I say this and then it will stick? You're always starting with SOHCAHTOA. That's the beginning and the end of trigonometry. You won't believe it.
I don't know, but I'm paying attention, so I just don't know the answer.
Okay, who else do I call right now? Just give me, I'm doing it randomly. Melissa, go. What is sine 60 degree? Melissa. Okay, next is Morris. Morris, what is sine 60 degree? Morris, what is sine 60 degree? Okay, who got it? Volunteer.
It's 2 over square root of 3.
Hold
I'm
on.
sorry, square root of 3 over 2. I'm sorry.
What?
Yeah, he got it.
Square root of 3 over 2.
Okay, that's correct. Next, I'm not going to write it. Next, Bianca Florido, go. What is cos 60 degree?
1 over 2.
1 over 2. That's correct. Next, Jonathan, I'm coming back to you. What is tangent 60 degrees?
Mr. Okebu, you wrote tan twice. It should be cotangent on the other side.
Yes, that's correct. Thank you. Thank you. At least somebody is paying attention. Chord, like COT.
COT.
Yes. So now, Jonathan, I'm coming back to you.
What is it, Mr. Yu?
Tangent 60 degree. Always look at the diagram, and then look at our general formula, which is SOHCAHTOA. Tangent is what? Opposite over adjacent. So now, give me the numerical value in fraction of tangent 60 degrees.
Square root of 3 over 1.
Yeah.
Opposite over adjacent. That's correct. Next, thank you. Next, Sarah. Sarah, what is cosecant 60 degrees?
2 over the square root of.
Cosecant is always opposite of 2 over square root of 3. Okay, that's correct. Thank you. That's correct. Thank you. Next, Tyler, go. How about secant? Secant of 60 degrees. Secant of 60 degrees.
2 over 1.
2 over 1. Okay, that's correct. So, Sarah, please repeat your answer. I want to write it down. Tyler, you are correct. Sarah, repeat your answer. I want to write it down.
2 over the square root of 3.
Thank you. All right. Victor, go. Cotangent 60 degree is?
I'm sorry. Just square root of 3.
Remember, cotangent tangent is opposite of adjacent. So cotangent is what?
Square root of 3 over 1 over 1.
That should be tangent. How about cotangent?
Yeah, cotangent. Oh, I'm sorry. 1 over square root of 3.
1 over square root of 3. So I want to write this one. 1 over square root of 3. Okay, so make sure, guys, that you completed the other ones. So now let's move on. And now I am going to say we can redraw the diagram to do for 30 degrees. So let's redraw the diagram so that we can do for 30 degrees. So just draw the same diagram, and instead of focusing on 60, now you are focusing on 30 degrees. And this is still 2, this is still 1, and this is still square root of 3. Now, in this second redrawn diagram, what is the hypotenuse? What's the hypotenuse in this diagram right now, in this diagram?
2.
Okay, the hypotenuse is still 2. How about the opposite?
Square root of 3.
Who agrees with that? If you agree, say yes and tell us why.
Because the opposite is always supposed to be the angle facing the hypotenuse, right?
There's actually no angle apart from 90 degrees.
I say angle. I mean side.
Okay, the hypotenuse is the side facing the 90 degree. That's established. Now, the opposite is always the side that is facing the given or requested angle. So we are no longer dealing with 60 degrees. We are now dealing with 30 degrees. Remember, this is a 60 degree, 30 degree triangle. So the opposite now is this side.
Oh.
And then the adjacent is now this side. Okay? Remember this, because this is where so many people make mistake. The opposite is always the side that is facing the given or the requested angle. So in this case, 30 degree is given. All right? So based on that, let us write our trig ratios. I'm no longer going to call names now. I am going to give you 2 minutes to write. I'll give you 3 minutes to write the entire trigonometric ratio, and then I will call each and every one of you to display their answer on the camera. So we are going to write sine 30 degree, then cos 30 degree, and then tangent 30 degree, and then we repeat the process and have cosec 30 degree, secant 30 degree, and then cotangent 30 degree. Okay, so I'm going to give everybody 3 minutes. Write it out. No use of calculator. Leave your answer in radical form. One more minute. Okay, who is done? I'm going to call everybody anyway, so if you're done, you might as well go for it. So display your answer on your screen, on your camera. Okay, Abu, go ahead. Tell us your answer, Abu.
All right. So right. So for sin 30, I got 1/2.
Yes,
For
go ahead. That's correct. Go. Continue.
cosine 30, I got square root of 3/2. And then for tangent, I got 1/√3.
Okay, so that's correct. Next person who hasn't said something. Carlos, go. Carlos.
For which one?
For secant 30 degree.
2/1.
2/1. That's correct. Go. Next one. Did you say? Yeah, I said that's. You said cosecant 30 degrees 2/1, right?
Wait, which one? The one.
Cosecant.
The first one on the right side, right?
Yes.
Yeah.
Okay.
And you want sec?
Yes,
sec
please.
2/3 squared. Oh no. Yeah, forgot what it was called already.
Yes, 2/√3.
Yeah, square root of 3.
So it is hypotenuse over adjacent, so which is 2/√3. All right. And Brenda Carino, finish it up. What is cotangent 30 degree?
It'll be square root of 3/1.
Okay, square root of 3/1. Thank you. That's correct. Now, ladies and gentlemen, we have accomplished a lot right now. Now, there is one thing that is left. Now, yes, and I want to emphasize it right now.
Mr. You, Gable?
Yes?
Did we say our answer or like?
No, if you showed me your answer, that's fine.
All right.
Yeah, so it is those who said that their cameras are not working. That's the ones I wanted to say the answer. And I wanted to write some of it down.
All right.
All right, so now let's do one thing now. Look at all these, look at the ones I'm going to asterisk. Look at these ones. All these ones that has square root sign on the denominator. So we are going to do what is called rationalizing the denominator. All right, so that's how to evaluate it. So like, for example, let's do secant 3. I would just say subtopic would be rationalize the denominator, and that applies only to the ones that have a square root sign on its denominator. So for example, sec 30 degree is 2/√3. So it has an irrational number on the denominator. So what you do would be you multiply the numerator and the denominator by the denominator. What did I say? Multiply the numerator and denominator by the irrational denominator. Okay, so now what all this long grammar, that's why I don't like too much grammar. All this long grammar, here's what it means. 2/√3 multiplied by √3 over √3. That's all the whole thing means. See how easy it can be? And then 2 times √3 is what? 2√3.
Yeah.
How about √3 times √3? √3 times 3, ladies and gentlemen.
Oh, it's 3.
3 times 3?
9.
Oh.
9. So √9 is what then?
3.
Yeah, so we have, all right? Okay, so now that's the way to do it. If it were tangent 30 degree, you can repeat the process. Tan 30 degree is equal to 1/√3. So finish up this one. Rationalize the denominator. You have 1 minute.